We will be talking about CephFS, but not going into very detail about CephFS. Generally, we will be talking about how we developed a new module within Samba for the CephFS integration. So I'm Anoop. I'm part of IBM and also part of the global Samba team. And with me, we have other two talks lined up after me. Our colleagues are also already here. And I must say that I'm not the original author for this new module. It is one of my another colleague, Shahar. I'll be presenting on behalf of him. So let's look at what we are gonna. Okay. Here is the agenda. So we'll be taking a quick look over the Samba and especially the VFS that we have right now, the modern VFS, and also a quick look at how CephFS works. And we look into the library for accessing, the client library accessing the CephFS file system, which is called the libcephfs, and how the new module itself was designed, what was the motivation behind creating a new module. And we look at the current module, the state of current module, and also how we arrived at creating a new module. And I'll touch on how we were continuously testing this development of new module. We had this testing framework that we have put into, so it was continuously tested on that platform. And we look at some conclusions, some findings, maybe some bugs that we discovered, and also a look at some of the performance numbers after making this new module, and some points to be looked at for the future. So Samba, I don't have to explain anything in detail here. We all know what is Samba. The first bullet point, I think it's something I got it from Wiki. And I thought it's the very simplest form. It's a free software implementation of SMB protocol, but we do much more. It's not just file that we do nowadays. We do print services, AD integration, and I'm focusing on the VFS side of Samba, the stackable VFS interface, the virtual file system interface that we have, which we use generally to connect to the underlying file system. Whether it is local, whether it is clustered, the CephFS, the file system, and also the cluster for GPF, these all comes under the clustered file system category. And the local file system was always a benchmark in the sense we always look at how the local file system integration works and the POSIX compliance works, and we always try to match how integration works with the local file system. And for Samba, we had this transition to the modern VFS using path-based, switching from the path-based old mechanism to the file handles. And we have various mechanisms that we are using internally within Samba code base, especially the OPath flag that we use in Linux. And there is the fallback mechanism that we use in case the OPath flag is not present. And there is this nice little document. I think it is also present on the wiki. It is called the new vfs.txt. It is in the code base itself. That particular document gives a nice overview of how the current VFS in Samba is written. And this has been a reference, at least for me, while making some changes in the new module, or even while creating the new module. We used to look at this document and see how this switch from path-based to file handle is handled for various VFS interfaces. So that has been helpful. Regarding Ceph, I don't know how many of you are aware of Ceph. I think most of you who are sitting here might be aware of Ceph. It's a large unified system which can do object, block and also the file system side of it. And we are focused on the Ceph file system side. It is built on top of a particular object store, which is called Rados. And I'll display one of the design that I got it from. Yeah, this is one of the CephFS architecture that we can see in the Ceph docs itself. So anything, the read-write from the client always happen. There are two different pools that we maintain in Rados, which is the base for CephFS. And the read-write from the clients always happen through the data pool. I mean, there is no intermediary between the actual data and the client is writing or reading. But when it comes to some metadata kind of operations, savior operations, we go through a particular layer called MDS, which is a metadata server layer. That's what we see. We go through some of the operations, and we ultimately hit the metadata pool. So this is a general. So I'll go back one slide. Okay, I don't know if it is. How do I go back in the slide?
Left cursor key? No.
Okay. Next, please.
Page
down. Okay, that works. Yeah. So we saw a general architecture in a diagram right now. So it is the CephFS architecture is highly reliable, easy to manage, and it is POSIX compliant. And we saw the metadata server and the data pools and we have a convenient client-facing library, and that's what we are focusing right now. There is a librados library also to directly access the Rados pool, and this is particularly used with one of the CTDB log helper that I think Martin mentioned in the yesterday's talk. We had some improvements in that area also. So we use this librados to directly put the cluster log file in the Rados pool and access it using the librados library. But now we will be looking at how libcephfs, or what does it contain. It is a native C API from CephFS side. It has correspondence to most of the system calls that we see nowadays, whether it is the OpenAT. It's just two examples that I have written. So it is basically prefixed with Ceph underscore. So you can get all these APIs from there. It is included as part of the header file libcephfs.h, and it is versioned. But I must say that it is not properly versioned, because there are a lot of changes that are going in, but we don't do anything with the versioning. I mean, I think it has been at version 2.0.0 for a long time. There are no changes that I have seen, even though there are changes going to the APIs itself. Yeah, but this is the version that we use currently right now. And there are two variants inside libcephfs itself. That is, a high-level API section is there, and also there is a low-level side to it. High-level API is that which is used most commonly, and most of the functions that we see, or the APIs that we see from the high-level section, matches most the standard system calls. They are just prefixed with Ceph underscore. You'll find, and these are all path-based and file descriptor-based things, and we have support for the @ calls. And these are some examples that you can see. And on the other side, for low-level API, these are more fine-grained, focused on inodes and file handles. And it has support for specifying the permissions per call, and also support for the supplementary groups. I put this point here because this is going to be the trigger for creating the new module, because that's one of the key or the reason that we looked at implementing a new module using the low-level APIs. And not to forget that we have support for asynchronous I/O. In the high-level API, the support is not there. The low-level API implements APIs for asynchronous I/O. And you can see some examples where it is explicitly mentioned as LL, which is the low-level API, Ceph LL lookup, Ceph LL open, Ceph LL put. So these are the semantics that we use when we deal with inodes. We get an inode, put an inode, and stuff like that. So let's come to the design part of the new module itself. So as I mentioned earlier, we have an existing module. It's called VFS_Ceph under source 3 modules. And it's consuming all the required high-level APIs from the libcephfs side. It implements, it is working. There is nothing wrong with that. It includes most of the SMB VFS interfaces that we use currently with the VFS layer. And also, it matches the behavior what we do with the default VFS module. It includes the path-based fallback mechanism. It is statically linked with the libcephfs library, the .so file. And these file system modules are mandatory to be loaded at the last one because these are all virtual file systems. And we cannot go through the default module because we don't have the file system as it is in the particular system. So we have to go through the library. If we miss one particular call, and it will be hitting the local file system, and it will cause problems. So these kind of modules are mandatory to be loaded as the last modules in the VFS objects list. And the file descriptors, they are all maintained on the libcephfs client side. And whatever FDs, the FD numbers that we receive, we report it back to the upper layer in Samba as it is. We don't do much about the FDs itself. So here is the trigger that we have been looking at. Basically, I would say Shahar, that's one of our colleagues. There was a bug existing which says that even though a user is permitted to access the file system as part of supplementary groups, not the normal user and group, it denied the access, even though the user is part of a supplementary group and is allowed to access. This was the trigger, and a merge request was created. And it was addressing the direct issue, like the bug itself was fixed. But we lost the ability for SMBD to switch, let's say switch to root to do some operations. This particular ability was lost because we were using a particular API from Ceph, which will internally make use of a fixed user group permissions. So the ability for SMBD to switch credentials was lost. So and we had a long discussion on that particular merge request, especially with David. And these were the two suggestions that we came up with. Why don't we shift to low-level libcephfs APIs? Because these low-level APIs has an additional parameter to specify the permissions itself. It can contain supplementary groups also. I'll talk about it in one of the upcoming slides. And another thought that we shared was to optimize the CPU and memory consumption, because right now, for each and every libcephfs connections that we make, the client connections, the entire libcephfs client stack is loaded. So let's say if we have thousands of client connections, we will have these thousands of SMBDs, and in each of them, they will have this entire libcephfs client stack. Yeah, these were the discussion outcomes. Yeah, and this was one of the hardest part. We needed a name for the new module. Actually, the initial attempt was to make changes to VFS Ceph itself, the existing module, but it might be a drastic change to change all the existing VFS interfaces to low-level APIs. And we came up with a plan to have a separate module. But the naming, it was a difficult process. I mean, I think VFS Ceph_LL was the first name suggested by Shahar, my colleague. And then it got another name called VFS Ceph2, then VFS Ceph Experimental, VFS Ceph Test. Yeah, anyway, finally ended up with VFS Ceph New. It seemed to me much simpler to use. But maybe in future we will have some replacement in the sense that we might replace the old module, the existing module, and maybe rename it as some legacy. And then we will have a VFS Ceph, this new module as the default. So the new module also resides in the same place under source 3 modules. So the initial implementation is based out of what we had with the current module, which is VFS Ceph using the high-level APIs. The interface itself were all same. And there are some very basic optimization that we have done to cache the libcephfs mounts that we do. This is only helpful to access multiple shares configured with the same user, Ceph user, and the same file system. And we can have that cache mount in use. As we discussed earlier, the operations are all using inodes and file handles. We heavily make use of the SMB VFS FSP extensions. There is a particular structure that we basically put in that particular extra area for the FSP, which is reserved for FSP. And we proactively add credentials using, we rely on the get current utalk functionality to get the current Unix token. And this is a particular API from Ceph, which has support for supplementary groups also. So we use this API as part of API calls, low-level API calls. And this is how we managed to fix the other bug, which was the trigger for creating this new module. And one important thing is that right now, with the new module, we no longer statically link against libcephfs.so. It is dynamically linked. This is what we put inside the FSP extension with the new module. Actually, it was a lot smaller. We had more improvements and more extensions to it. So we have the caching part, the user permissions, the FSP itself, and there is a config structure that we maintain. So those were the improvements that I will be talking about in the next slide. The actual file handle itself, and FD, and some open flags. I don't think we need open flags and FD right now to be put into the FSP extension, but for some reason it was there for the first time itself. So we expanded further. It was the basic structure, and now I'll be talking about some of the improvements that we have made. The very first one is related to the introduction of a proxy mode, and this is something we'll have. The very next talk is about how the proxy mode is working, what was the intention. So it is basically to scale the client connections, and we will hear more about it in the next talk. We did a lot of structural reorganization. Actually, the VFS Ceph config structure itself was introduced as part of this effort. And we abstracted all the module-specific options and parameters into that particular structure. And we are currently loading dynamically the libraries based on the proxy mode, whether we operate with a proxy or without a proxy. Depending on that particular mode, we dynamically load either of these library, whether it is libcephfs.so or libcephfsproxy.so. And we had a switch to use Ceph redir-r, which is a re-entrant version of redir, which has correspondence to the normal redir and redir-r functions, APIs. And we added the non-blocking APIs to support the asynchronous API, asynchronous I/O. They are detected during compile time, and some structures for T-event management were also added to that VFS config. And very recently, we started taking advantage of the case-insensitive CephFS volumes. This was a recent feature that got merged into CephFS. So we can make a CephFS volume case-insensitive or sensitive with a particular setting. And we identify this during the connect function, the SMB VFS connect interface. Or is it using, okay. Yeah, anyway, we use the particular flag to mark it as file case insensitive based on a particular extended attribute that we can fetch from the CephFS subvolume. So we get to know whether the underlying file system can support, it can act as a case insensitive file system or not. This is the whole VFS Ceph config that we currently maintain. And there is a cookie kind of thing that we used for caching for local caching of mounts. And this cookie has to match these three values here. So the conf file for Ceph and the user ID and the file system name itself. And we have the proxy mode options and the library handle for dynamically loading whichever is the library, whether it is a proxy or the normal one. And there is a capabilities field added. That's also a recent one. This has nothing to do with the capabilities from the CephFS side. There is a capabilities concept on the CephFS side. This capabilities is purely from the Samba side. Whether we add a particular capability for a particular file system, this particular field is just for indicating that. It has nothing to do with the CephFS capabilities. Yeah, let's look at what we did to get this tested. So we had a talk in last year's sambaXP explaining or detailing on how we developed a Samba integration testing platform. It is an Ansible-based testing platform. You can refer to that talk, how it works. So we use the same platform to test this new module. Basically, even though it is a new module, we can just create a new share, replace the old VFS module with the new VFS module, and we can test it. There is a possible integration for the GitLab CI that we have upstream in Samba. That's something I have to propose, and we have to see how it goes. And as part of this testing framework, we include a subset of SMB2 torture tests. Not everything, but we could find that subset that we are using is good enough for us. We will see why in the next slides. And we test various share combinations, the kernel client-based shares also, the old module, the new module with proxy mode. So we have 4 to 5 different shares configured with a particular setup. Okay, so this is what I was talking about. So this is kind of a projected view, how even if we manage to get this integrated to the GitLab upstream CI, we will see an external job listed as here. And if you are making use of some labels, if you set particular labels on the particular merge request, you can see that this is running. So this job itself is not running on GitLab CI. It is external to GitLab, and the results can be viewed if you follow this particular link. So this is a projected view, how it may look like once we integrate this testing framework results with the current upstream CI. If you follow that particular link, you will be directed to a Jenkins-based console output, and you can get the artifacts, the test outputs, what were the results, these kind of things. You can follow various links from there. So what did we find after creating this module? This is going to be functionality-wise what we found after creating it. So as I mentioned, we run few of these torture test suits, a subset of torture test suits, and we noticed a lot of failures here and there. I am pointing out a few of them here. We had a particular failure with SMB2 car set test suite. This was caused by a reorganization around retrieving the FS capabilities itself within Samba. And I made some changes and some reorganization, and we could fix it from there. And we detected a Ceph MDS side crash. This was triggered by some code path. We are testing this on a fast-moving master branch. So there are a lot of changes happening in Samba master branch, and somehow some of the cleanups done on the SMBD side, I think, triggered a different code path, and it was hitting a particular place where it crashed the MDS. It has nothing to do with Samba, but we got to know that there is a problem. And we had another libcephfs crash when snapshots were integrated with CephFS. Yes.
A very quick question. Which bug tracker are these? With these numbers? No, ones below. Yeah,
Those are the Ceph trackers.
Ceph tracker.
Yes. I mentioned it as tracker because the URL itself for Ceph, it's called tracker.ceph.com. So I mentioned it as tracker. The very first one is from sambaXP. Yeah, and while handling snapshots, we encountered some libcephfs side crash, client crash. And this was a very recent one, smb2.rw.rw1, the torture test failure. This has to do with the asynchronous I/O implementation within Ceph itself. Actually, it is a very special case that I saw from the torture test case. I think the tracker itself is still open on the Ceph side, because there are some problems with the APIs itself. Yeah, so we realized that SMB torture is a good bug detector, basically, for us. We could find a lot of bugs, whether it is in Samba, in the implementation that we use, or even on the CephFS side, we could see a lot of bugs. Yes, and few points to be looked at for the future. So we do a local caching, and if the underlying file system and the user happens to be the same, and the client connection also comes through the same SMBD, we used to have this caching, and we could look at integrating it with the memcache itself. Right now, it is a separate cache that we maintain. And then we have a zero copy API that is under active development from CephFS side. So we could use that interface also. And we look at how is for any the memory usage, and probably detect any leaks. And as I mentioned earlier, we could try to see how it works with our GitLab upstream CI. We don't have to look back and see which particular change from Samba or which particular cleanup change from the Samba side was causing a problem with CephFS integration. If we could test it on the going, whenever a merge request is being created on the Samba side, we get an extra job to get these things tested. So we have the framework and everything ready on the side, on our side. We just have to integrate it with the GitLab CI. So it should be, it should be doable. Maybe we can propose it to somewhat technical and see how the discussion goes. I think that's it from my side.